if I look at my career for 30 years or so, and I saw the evolution of data centers, and they did evolve, but there are always small incremental improvements in performance, in reliability, improvements in efficiency, improvements in architecture. They're all good, but nothing significant. And then all of a sudden we have this disruptive transformation that AI data centers doesn't look at all like the same type of data center that has been designed and built and operated for 20 years or so. So these are exciting times, really interesting, and probably the main reason I'm still around and still so active is because I'm so excited about this, and I enjoy looking at the transformation of this business.
I cannot think of a better way to start a podcast than that. Thank you very much for kicking it off for us. Let me ask you this, Peter. In fact, I guess my comment is, as you're describing that, it's almost like you're standing on the beach of time, and for millennia, you've been looking at this really still ocean with slow single cell growth and whatever, and then all of a sudden, like the fossil record, there's an explosion. There's, things crawling out of the water. There's things flying over the water. There's things swinging from the tree, like calm in the rock, and then, this explosion of activity. So we'll come back to that in just a second. For the audience who doesn't know the amazing Peter Gross, how can you just take a minute to explain, or a few minutes to explain, either from now going back, from the beginning to now, bring us up to speed on your background and how you got connected to critical infrastructure and data centers?
Well, like anything else, it's a lot more than anything else. Mm-hmm. You look at your career, my career, most of people's careers, it wasn't really planned, but you bound to it. And, I'm an electrical engineer by training. My background is power electronics. I started working at a company that designed power systems, and one of their products was a UPS. Nobody I knew much about UPSs, and working on these UPSs, I was chief engineer of their 400 hertz product line. Introduced me to data centers. I started to look at these amazing installations. In those days, data centers, designing a data center was more of an art than engineering. It was, and I hate to say that, but it was almost, the notion of money is no object. Well, right. Data center was really in the realm of financial institutions and banks. So when I started learning about data center, I joined a small consulting firm that was primarily focusing on financial institutions. So I became the main data center consultant for the big banks in New York, primarily New York, for New York Stock Exchange and Merrill Lynch and Bankers Trust and Citicorp, Chase, and so on. So yes, in those days, these financial institutions, like today, they could not operate without their mainframes, without their data centers. It was vital for these data centers to be truly 7/24 to be operational, and that gave me an appreciation of what reliability was. But in those days, a good data center was maybe 800 kilowatts or so. It's a long way from in a few years we're going to see a rack at 800 kilowatts. So
right.
That would give you a sense of how this business has evolved. So I've been doing this for a number of years, and then I decided I'm going to start my own engineering firm. It was part of an architectural firm. It was called UIP, and I was founder along with the managing partner of the architectural business, and built a consulting firm that was pretty good, especially during the dot-com. We captured probably 30 to 40% of the entire business. The business survived the nuclear winter after the dot-com implosion, primarily because it still had all those financial institutions as clients. Mm-hmm. And then, the company grew to be the largest, and I would say, that might be a little subjective on my part, the best engineering and consulting firm dedicated to this business in the world. And we did a lot of big data centers in the United States and in Asia, in Europe, and South America. It was a very successful business that we sold towards the end of the first decade of the century to HP. Mm-hmm. And for 4 years, I was the managing partner of the HP consulting business, primarily focusing on data centers, but also energy and sustainability. That those were the early days of interest in sustainability and energy, for that matter. Mm-hmm. After 4 years, I decided that it's time for me to retire, and I stayed retired for almost 2 weeks. And I recognize the fact that I'm not ready for that. And I joined a very interesting company called Bloom Energy that's making these very interesting fuel cells, solid oxide fuel cells that convert natural gas directly into electricity through a chemical process. And my role was to run a business unit that introduced for the first time fuel cells to the data centers. And remember me and Dean Nelson building the first major data center using fuel cells at eBay. And then the business grew, evolved. And for the last 4, maybe 5 years, I was I'm still very much involved in the business. I sit on a number of boards. I'm an advisor to a fairly large number of companies, probably too many. I'm a consultant. I'm involved in some very interesting designs. But it's all related to data centers. I'm fascinated by all these innovations, all the new things that are reshaping this industry. And as I said before, it's a very exciting time. If you're in this business, this industry, this is the time to reach for it because it's unique. It's different than there's anything that happened in this business in the past 30 years, and probably it's not good. We're not going to see the same exponential growth until we're going to see the next generation of maybe quantum computing
till the next thing that we can't predict comes up. Let me ask you this, just out of curiosity, what do you think that time span is? That 30 years related to this, 20 years, 40 years? From what you described, from that consultancy to the financial institutions and the banks to hanging out with me last week at an event, how long is that time span?
It was about 35 years.
Yeah. Here's what's incredible. I've only got to know you in the last year. I've known of you, but I've only got to know you in the last year. Almost certainly everywhere I go, when Peter Gross's name comes up, people respect you. If they don't, they've never brought it up to me. But that's not what's so surprising for someone that's had a career like that long. To be a consultant, to have moved through all of these different groups, and for people to have genuine affection and love for you over and over and over behind your back, that is a life well lived. And I've always, I thought that's an incredible testimony to a human being when you're not in the room, you've got a long history with a group of people, they don't know if we're connected or not connected, and your name comes up and they speak of you, even if they disagree with an idea, but they speak of you with affection, that's incredible.
Well, Dave, now I'm blushing. It's awfully kind of you.
It's the truth. It's the truth. Hey, let me ask you this. So, to your point, right now, we're just being disrupted. Like, it feels like, I love your initial analogy of, you have this incremental change. So it's sort of like, once upon a time, we figured off, we want to leave the shore, so we build these canoes. Then we figure out how to make a keel. Then we figure out how to make a sail, and we start figuring out how to navigate, and we're trying to, get away from the shore and do these other things. And, as humanity grows, and then like 6 weeks later, we have an aircraft carrier, like a nuclear-powered aircraft carrier. It feels like it's sort of this traditional growth, and then all of a sudden it's, So what, as you see the things that are fundamentally disrupting our industry, what do you think about that? Not so much the design, we're going to talk about that, but what are the things that are really disrupting and that we're this is the reaction that the environment's having? Some agent's been introduced, the body's responding with cell production. What is it that's causing all of this, do you think?
Everybody talks about the power shortage, densities. For me, probably the most significant difference is size. Size is the most extraordinary thing about how this business has evolved. It's unconceivable a few years ago to think about a 1 gigawatt data center, not campus, 1 gigawatt data centers.
Right.
There's talk about 2 gigawatts. I have my reservation about that, but the magnitude in terms of power, in terms of money, the cost associated of building and operating these facilities. And the other thing that is extraordinary is the speed of this transformation. We talked about AI for the past 5 years or so. And it was something coming, not know exactly how it's going to look like. And we all knew that it's going to have a major impact, but it was still somewhere in the future, rather nebulous. Mm-hmm. And now, in less than 2 years, all of a sudden, we see this extraordinary explosion. And at every level, the speed of development, this ChatGPT came out and changed the world, and this is just the beginning. So I think that the most extraordinary thing about this whole thing is magnitude more than anything else. And everything comes with it. The densities and the technologies that will enable us to achieve those densities, and the architecture, system architecture, and the whole adjacent infrastructure, the network and the storage and the security of the new power sources, power technologies. Obviously, the cooling technologies, all these things are developing as we build, which is a bit scary, but it's part of this process.
It is, and yes, the speed at which we need to respond, the scale is crazy, and the other part of speed is for a data center operator like ourselves. We went from building, a data center every couple of years, maybe 2, at a much smaller scale, to 7, 8 a year. Right. And under the same sort of pressure, like we've imagined, whether we've converted a brownfield building or we've developed a greenfield to deploy, we hear people all the time talk about in our industry, used to be a 7-year lease. Now it's a 10 to 15-year lease. I want that building to get me 200 years down the road. I don't we're not trying to build an infrastructure that we feel like we need to level 15, 20 years down the road. I need that thing. Can you imagine all the just from a sustainability and the money and whatever, if I've got to knock all that down or a significant portion of it to redo it again. And so for operators like us, I'm looking at that asset, I don't know a single competitor or frenemy in the space that only expects that infrastructure. Even our friend Tony Grayson, when he talks about modular stuff, that the internal may have to get changed. The mission may change, but we expect to get a long life out of these devices. And so the scale, the speed of change, and the speed of deployment is, I don't know a parallel. Even when we look back at the Industrial Revolution, railroads, telegraph, whatever, electricity, a design was decided more or less with incremental changes, and then it was deployed. And now we're reacting to, the design from yesterday. Well, we don't know if it'll handle the new things that'll be coming out in 18 to 24 months from now. So that scale and speed. When you, yeah.
Just look at the evolution of NVIDIA GPU, right? We went from A100 to Hopper, then combination Hopper, Blackwell, and from the next generation is going to be Rubin in a few years. I mean, and the densities, the rack densities goes from 40 kilowatts to 110 kilowatts to 220 kilowatt. 130 to 20, and then from there, talk about 500 kilowatts and even a 1 megawatt cabinet. So you build a data center today for and all based on Blackwell, and you build the entire infrastructure based on that, and then 2 years later, all of a sudden now we have the next generation GPU, and the demand, the numbers are doubling again. Can you adapt that data center to the new requirements in terms of power and density and so on? It's that's one major challenge. Think about it. It's one thing to bring 120 volts to the cabinet, and it's going to be a totally different thing when you're going to bring maybe 4160 volts to the cabinet, and it's one thing to do rear door cooling for a 40 kilowatt solution, and convert that to liquid cooling when we're going to have to remove 220 kilowatts worth of heat from the cabinet. All these things are going to be challenging. Yeah. So, I'm not describing the new design requirements here, but flexibility flexibility is going to be enormously important. In the past, as I said before, the design was fairly static because the technology did not change much. You have a refresh rate of 5 years or so, but the new servers were not very different than the previous one in terms of power and the cooling and so on. But now this whole thing is fundamentally, violently different.
Yeah. Let me ask you this. As you described that, it got me thinking about a conversation I had recently, similar but not related. There was somebody talking to me about aircraft design. And they said, look, there is a in their world, an explosion of aircraft design, both in efficiency, comfort for the passengers, technology within the airplane, even the scale of planes for the first time in a long time. They built all the way up to the A380, this big double-decker Airbus. And then, but they had to, there were a couple things. One, they had to operate within, look, the population that you're trying to serve, there's only so many airports that those planes, these big giant planes, can fly between. The runways are only so big. There's noise requirements. Like there's only a certain amount of available fuel. There's a certain number of technicians. There's a cost to these things. To make incremental changes to them, in other words, to take them out of the line, to do maintenance or whatever, like when you add up all of that, we can build bigger, faster, stronger, whatever planes. They've been flying at about 35 to 40,000 feet at about 500 or so miles per hour for the last 30-something years. There's a reason why we don't go much higher than that. There's a reason why we don't go much lower than that or much faster than that. Because I've got to survive in the broadest markets possible. And even post-pandemic, they began mothballing most of the big A380s, and they'd even rather retrofit a 747 from the 70s or 80s than fly some of these, at least according to this conversation. I didn't fact check it. I'm wondering in our world, as we think about innovation, because so many of the things that you just described, there's got to be power innovation, there's got to be material innovation, there's got to be cooling innovation, there's got to be space. Like to do a 200 kW plus rack, besides the area that you talked about bringing this really, a lot of power to the rack. Is that going to still be AC? Are we going to switch it to DC because of the size of the copper cables? Is the training necessary now for a technician that's essentially got to handle medium voltage power that used to go into a vault and only a few people talk there, and now we're bringing that out on the floor? Like how do we change that? All of that innovation. And when somebody was talking to me the other day, Peter, just the space constraints. If you remember, like 2 years ago, it was like, raised floors is going to go away. And now they're like, no, you got to bring it back because I've got to fit these things underneath it. But the reason why raised floor was going to go away was because of the weight of all of this infrastructure to the concrete below. And we didn't think the tiles and the stanchions could hold up to it. And now people are telling us, no, we can solve that. So just so many areas need innovation, the training, the art of snapping these Legos together. And if you build a complex system like that, to your point, for the longest time, we were trying to work simplicity into designs. Why we liked air and other things was because I was working to make data center designs simpler and simpler, more and more modular, more and more Lego, like snap apart and whatever for speed and all these other things. And now it feels like, we're trying to, when I pop the hood on, I guess what I'm trying to say on my truck, the amount of technology under that hood compared to my grandfather's truck from 1978, his old Ford 150, that I could have fixed literally under a shade tree in half an afternoon, almost anything but an engine block. And today, I'm not even sure which valve to unclick, or I start with a computer connecting to it. And so we have all of these things going on. Are you seeing any innovation, or what are the components of innovation you're seeing right now that you think are really making headway in the midst of all of this complexity?
Well, yeah. Well, let's take power for instance. So right now, you look at the Blackwell type cabinet. You have 18 compute trays with Blackwell and Topper, and you have some network trays, and you have some switches, and you have 8 power trays. Mm-hmm. There are it's the typical configuration. Most widely used technology right now is to use a 4 to make 3, a 33 kilowatt power supply, and have 4 of them plus one redundant, so that gives you about 100, and then you have another set of 4 at the bottom of the cabinet, and so that's another roughly 100 kilowatts or so. So the whole 42U cabinet is full right now. So now you're going to go to the next generator, 220. So the question is, how are we going to do that without occupying the entire cabinet with power shells, right? So, you know, there are companies now around it, Vertiv and others are looking at new technology. Delta is there, and DG Matrix and a few others building power supplies that are even denser than that. Using new technologies, new type of semiconductors that will enable efficiency. That needs to, efficiency on a little box like this have to approach 99%, because otherwise you have so much heat you have to dissipate inside right. the cabinet. So we're going from that to maybe 40 to maybe 50 kilowatts, and the next generation is going to have to be like at least 80 or even higher, and it's going to have to be water cooled. So that technology is now starting to develop, and I don't see any other solution to be able to distribute power into a 220 kilowatt cabinet. And the power coming in, think about the amount of copper that it's going to require to bring these busways. Going to be gigantic, and think about that. This is a 600 millimeter width cabinet. We're probably going to have to go to a little wider cabinet, maybe 720 millimeters. It's going to probably be it's deeper. It's going to be obviously taller than that. So how are we going to bring power? Obviously, we're going to have to go from 415 volts to maybe 575 volts, and now discussions about medium voltage. As I said, 41 5 kV or maybe even higher than that. One option, one solution I'm looking at, and I think is very interesting, in using HTC, hot superconductivity. Superconductivity is this material that has essentially zero resistance but at temperatures approaching 0 kelvins, very cold. But now there are new technologies that can have pretty much the same attributes at minus 200 degrees C, which is manageable. It's liquid nitrogen. You can cool them, bring them to that temperature, and now you're going to be able to carry 10 times more current in the same conductor. Mm-hmm. So now, if we do that, then we probably can simplify the whole distribution, and it's going to be it's very crowded there. You're going to you have the network, you have the power, you have the liquid cooling, you have fire protection probably on top of it. I mean, just you mentioned raised floor. There are discussions about bringing the water to the cabinet below, as opposed to have it on top of the cabinet. So when you have a $35,000 GPU, you really don't want to have water getting there for obvious reasons, and maybe bringing it below floor might be a solution. So, and then you have a cabinet like this, which is about 1.5 tons. So you have a little challenge there as well. And then you have the whole prompt proxy. It's called spiking waveform. This unique waveform associated with training as well as inference, and that's causing an enormous amount of stress among operators and designers, because this kind of waveform is could have a major impact, disruptive impact on the entire infrastructure, supporting infrastructure, on UPSs and on diesel generators, on transformers, and certainly on utilities. When you have this kind of variation, vast variations repeated thousands of times an hour. Utilities are not accustomed to do that when you have a 300 megawatt data center. So all these things need to be addressed, and there are solutions. There is a lot of work, interesting work, that is going to be done in order to address these issues. And then on top of that, you have all these issues about power and power availability, and then you want a lot of power, and you want inexpensive power, and you also want green power. Well, good luck. These days, lucky to get power. Forget the cost and forget the green piece of that. But then eventually we're going to have to address this, and whether we're going to go to distributed generation, or we're going to, like we discussed, maybe do either CCS, carbon capture and sequestrations. We're going to go to other type of distributed generation, SMRs, or even fusion. All these things are all converging together in these domains, and we're gonna resolve all these issues. We're gonna address them properly, but they are really becoming prevalent today as we speak. The next 12 to 24 months will be essential in reshaping the whole data center business.
Sounds like what you're describing, and I think you're even then, in the interest of time, cut out talking about network in detail, the innovation that happens there, storage in detail, the innovation that needs to happen there, training in detail, like all of these, so many other components. And I'm smiling because it sounds like this would be a conversation out of NASA. Okay, so here's what we're going to do. We're going to travel outside of our galaxy. Well, wait, we can't even get to Alpha Centauri. I know, stay with me. So we got to invent how to do wormholes, and we got to invent materials that can handle the heat of the sun and the coldness of space, and we got to invent communication, and we got to invent a supply chain, and we got astronauts that can, suits that can withstand radiation, and they got to be able to do hyper travel and on and on and on and on. Sound easy? And we need to do it in 36 to 48 months. And we have, we have these goals, and here's the things, and we're, at some point, you said something before that I love to say when I caught you in a pretty candid moment. You're always candid, but I love this. But there's uncertainty. So we go to these engineers in any of these different respective areas of expertise and say two things. One, innovate. So that when I go to deploy one of these platforms we keep talking about, Blackwell, Hopper, A100, whatever, which are, for the people who don't know, these are compute platforms that live in a rack. In previous times, it would be stacks of computers or blade servers or these other things. This is where all the ideas live. And they do calculations, whether they're GPUs or CPUs or whatever. These are the compute things that are doing compute work. And the network that has to be, we believe, in close proximity for latency reasons or whatever. So you've got all of this complexity, and we have a time frame we think that is, I've heard it from 24 to 60 months, whatever it is, for some of this to be solved. And at the same time, it's butting into, well, we have sustainability and ESG goals as a corporation. This is serving, whether you're a big hyperscale data center company or you're an insurance company or whatever, we as a whole company have goals to meet certain requirements, and we take them very, very seriously. And these things seem to be bumping into each other. So how do we do this? How do we serve these things, but not lose this connective tissue? And then when you started talking about uncertainty, I've heard so many people come off of a stage where they're standing there with certainty, apparent certainty, here's what we're going to deploy, and here's what our design's going to look like, and this is what it looks like. The smartest guys we know and gals we know. And then when they sit at the table with their cup of coffee with us on the side, like, wow, you saw that? Well, kind of. Like, it seemed to work in the digital twin. Like we think, in my Etch-a-Sketch, it seemed to work okay. But nobody has one of these, right? This is the best minds as I collaborate with my partners. And so you have to lean into this uncertainty because of it, in order to get it to work.
Think about it. We're talking about the next generation training AI data centers. But the fact that we still don't know how machine learn, here we are developing these extraordinary AI platforms that will totally change the world. But we still don't understand how these machines get to be so smart. And I'm sure that we'll learn sooner or later. Then probably the way we configure these training facilities will change to respond to that. And then next step, obviously, inference is gonna change. And then we're going to transition to the federated AI and the edge AI, and we're going to go through some very rapid changes within the confine of the AI structure. So it's going to be interesting. And coming back at the other end, how do we in everybody talks about power shortages and so on. But probably more importantly, at least for me, is how we're going to collaborate with the utilities. How we change this relationship between utility and data centers. Data center being a passive user of electricity, or they'll pay their rates, and that's the end of the relationship. How data centers become an active element in the whole grid behavior, and especially how we help utility maintain reliability, because that's becoming a very serious concern. And equally important, how do we make utility friendlier with the neighborhood, with you see, which is kind of worrisome. You see communities becoming vocal about not wanting data center in their neighborhoods. And data center have to become more involved in the whole community. Prove to the community that they bring significant benefits, not only in terms of financial performance, but in terms of supporting the infrastructure there, maybe being a disaster recovery component. I mean, there are many things that data centers can do, but the community has to address this problem, because they are not going away.
For sure. I mean, if we let somebody else tell our story, they're not for representing. Let's just give everybody the benefit of the doubt and presume they're trying to be honest and authentic, but they may not be accurate in anything, whatever it is. And so, if we're bringing technology or a facility or an idea or a medicine or whatever it is to a group of people because we believe it's for their good, we better be able to articulate why that is, and we better be able to understand why they don't think, instead of just showing up with a chart that says, we could make you money and this could do these things. Like, what people usually, the reason why they react like that usually is they're afraid that you're going to make a material negative impact to them and to their children. Whatever it could be. It's too noisy, it's too congested, it's too loud, you're taking my water or my power, or your
increase the price of electricity, and
that's right.
Real estate value.
That's right. All of these things. And not all of those things are unfounded in every circumstance. And so we need to make sure that we don't fall into the trap as a community or an industry of, here's our 4 talking points, or here's our 4 bullet points. Let's just go. If you don't get these, you're not, you're not paying attention. That is 100% the wrong way. How do we sit down and because a lot of times when I go to a community that's not educated, they think we're trying to trade land for glass beads. They think there's a trick or something. And we better go in and first listen and understand, make sure we understand what the real concern is. And is the thing that we're bringing actually, in point of fact, not negatively impacting them for whatever the thing is? And in addition to that, what are other ancillary benefits? And so I just think we need to get more sophisticated. In the past, we've got a bunch of engineers, a bunch of introverted engineers with and I love them, God bless them, because I wouldn't get on an elevator or get in a vehicle without engineers making sure that's safe. But they're not always the best storytellers. And by storyteller, I don't mean deceptive. I mean, let me capture the big idea in a way that human beings, kind of like music, in a way that transcends, the minutia into the big idea. There are a lot of people are talking about it, but one of the things that you said earlier when we were kind of talking about this innovation and how these things now are evolving, billions of dollars are being spent on solutions that are going to get deployed in our data centers, those that you consult in, those that I build. And there's a certain level of trust. One of the things that sort of a accidental happy circumstance that's happening is I've been at a number of events or these advisory boards is people that are competitors are more and more talking about, they're more and more being transparent about the risks they're facing and trying to solve so that we can collect. It's not perfect yet, but it's much different than it was even 5 years ago, that's for sure, maybe even 3 years ago, about I'm trying to solve this, whether it's one hyperscale cloud provider talking to another one in a room, and we're all trying to figure it out because we're uncertain. They're smart people, they're capable people, they're used to doing hard things and solving problems. But things are moving at a scale and a speed and require such a wide breadth of innovation across so many disciplines that if we're not transparent at these things, it's not just going to be, well, that cloud provider or social media or e-commerce, they missed it. No, it's going to be significantly impactful across a swath. And so that transparency is required. There's just too much at stake.
Yeah, OCP was a good example of finding a way for the various companies in this space to collaborate, and I think it was very successful. The objective there was to improve efficiency and reduce costs that benefits everybody. And I feel that this kind of initiative is even more important now because we're talking about much larger projects and much more expensive endeavors here. So I think that finding a way for developing a 1 or 2 gigawatt data center campus, where you're going to bring some of the hyperscalers together in the same space. Finding ways for these hyperscalers to collaborate and improve the major utilities, gas, power, fiber, so will benefit everybody. Finding ways to find sources that are greener. Once again, all these companies have very aggressive, very ambitious carbon reduction goals, and will benefit everybody. So, the same thing about the whole supply chain, and bringing some standardization here will reduce the cost of equipment, whether it's power equipment, cooling equipment, and so on. All these things will have to happen because ultimately, the financial issues and the sustainability issues are very very significant and affecting everybody. So
Yeah.
I believe that that's the only way to address them is to bring all these players together.
One of the things that's dominating the conversation today, I'm not sure how to feel about it, is this idea of microgrids. Now, I'm not anti-microgrid, period. We have microgrids in data centers today because we have UPS infrastructure. We have backup infrastructure, usually in the form of generators or whatever, and those are, by definition, microgrids. But what they mean is self-generation. So either on the property of the data center operator or adjacent to it, let's build some form of a generating plant, whatever that might be, natural gas, hydrogen, whatever. I got a generation plant here, nuclear perhaps in the future. And one of the reasons for that is there's this attractiveness to, there's this idea that perhaps I can move faster than working with a public utility. One of the things that in our small circles is talked a lot about, but not so much in the broader circles, which is equally challenging, if not in many cases more challenging, to creating a generation plant is getting transmission and distribution from one location to the other can, spectacularthis hard, not just in the area of nuclear, in any area. I don't care if it's hydropower coming from a dam 15 miles up the road. This is not 1952 Eisenhower America where I can just build interstates wherever I want them. This is not, it's equally hard for fiber, for right-of-way. And so there's a lot of conversation. Many of my friends are that I've made over the last few years are in this space, and data centers like QTS are evaluating the potential of that, I think would be fair to say. Do we have one nearby? Do we go into a co-op with 2 or 3 frenemies? Do we own it ourselves? Do we do it in partnership with the utility, but we fund, like all of these things? What do you think is the attractiveness to it? And what do you think are either the benefits or the risks, maybe that we're not really talking about, that we should be thinking about?
Well, I think the main driver, obviously, is power, unavailability of power. The projection is that about 35 gigawatts worth of power generation will have to be decommissioned in the next 5 years or so in this country, and maybe only 15 to 20 new gigawatts of new generation would be constructed. But I think that more important than generation is the transmission issue. It's very difficult. It's so difficult to build a transmission, just like you mentioned, a transmission line to bring power from regions that they have available capacity to regions that need it. There are so many attractive locations around the country, around the world for that matter. Probably Europe is even more constrained than we are here. Where data center want to be because of the gravity pull cannot develop anymore because of lack of power. I'm involved with a number of projects like this, and it's becoming more and more attractive for many operators to build their own power generations. And one of the reasons it's attractive to hyperscalers and the data center providers is the fact that you have more control of your power destiny. In other words, you can be in full control of the amount of power. You can take measures having to do with the sustainability of the green component of the power supply. You can optimize the power supplies, assuming that you have a microgrid that includes, in addition to the recips or fuel cells or turbines, includes batteries and inverters, maybe diesel generators, maybe some renewables, having the ability to optimize that based on cost or efficiency or sustainability. So you can do arbitrage. There are a lot of things that companies are attracted to that cannot be achieved being simply a consumer of electricity from the grid. Look, Ireland had on-site generation because of the shortage of power there. We were probably at least 10 different off-grid on-site generation solutions using primarily recips or turbines. There are more and more installation using fuel cells because they have some advantages. They're quiet. There is no smoke. The emissions are much lower, and they have some really good power quality attributes. You expand that. Now there are discussion about DC distribution that will totally substantially simplify the architecture of the data centers, and also that will benefit fuel cells. Discussions about using absorption chillers in the CHP arrangement, using the exhaust from either from turbines or recips or fuel cells, and also the ability to capture the exhaust, which is and get the carbon and find a way to sequestrate it. And I think that the data center of the future will have these attributes. We have to address the carbon, we have to address the cost, we have to address the efficiency. All those things need to be looked at, evaluated holistically, because there's each new solutions will have an impact that will affect other elements of the data center. And it's going to be, a lot of these solutions are available today. They haven't been implemented yet, or they have been implemented on small scale. But I envision that, in 5 years, we're going to see data centers that look totally different than what we have today.
So on the positive side of that conversation, I can imagine if it were, as an operator, to be able to go to a community and say, I want to bring spectacularly clean, if not carbon-free, but whether I'm using carbon capture with some pre-nuclear technology or some intermittent, and I've got the right storage mix to make intermittent real for base load and for these other things, and to be able to have a surplus then, so I can bring to a community, not only am I bringing enough for whatever we need, but I'm bringing an abundance to feed back into the grid or into the area. So what an incredible story if I can bring safe, available, affordable, consistent power, whatever that is. Like, as far as I'm concerned, you're not connected to the economy if you don't have that description of power and connectivity. You got to have those two things in order to be connected to the economy. And so that's an incredible story. But as you were walking through some of those things, it reminds me of my buddy Brian Jabek and I, who used to be at an Enchanted Rock. And when I was just getting introduced to the conversation, he said, I don't know. I said, well, where do you think this is going? He said, I'm not sure, because data centers, or most businesses, don't want a whole bunch of regulation. And if you think you're regulated now, go get into the power generation and distribution long before we get to nuclear, small modular reactor, or anything. It is an order of magnitude. It is not, as somebody said at a recent event, look, if it's $100 to build a small modular reactor, $1 of that is for the technology, $99 of that is for the paperwork. And so it's just a level of sophistication. And I'm not saying no, I don't know, but I just think it's order of magnitude more complicated than just what are the speeds and feeds? How do I install this turbine? How do I connect it to a source? How do I secure it? How do I make sure I got maintenance and all the people necessary to do that? And it's, in other words, the technical solution. The regulatory things at the federal, state, and local level are in my new experience in thinking about this, are so much greater than we imagine, and we don't live in that space. It's almost like when data centers began instituting, in some cases, armed guards. Like a couple of my sites they don't just have armed guards, they're seriously armed because of the types of things that they're protecting and the animals that they use to assist them. That order of magnitude and safety protocol and insurance and rules and regulations and points of entry is orders of magnitude different than a 500,000 square foot data center down the road. Might be a bigger data center with equal to power, but the risk profile is so much different. We have to have specialty trained, not just security people, but management, infrastructure, all these other things. And so that's why as we talk about innovation around distribution and microgrids and all of these technologies, which are spectacularly important, and the benefit of whether you're large enough to do it by yourself or you are just as likely partner with 2 or 3 other major well-funded institutions to do this, just think that the complexity is beyond the technology. And do you really want to do that? Maybe you fund it and let a public utility, I don't know, I'm just out loud trying to think about how do we not inherit the regulation, let the experts do that, but we fund the infrastructure so that it, just like a lot of us, we're not in the green energy business, but we fund so much green energy innovation, whether it's through PPAs or other things, and we let the green energy people figure it out and get smart about it, and we're the benefits and our co-citizens are the benefits. But I'm learning. I'm really fascinated by the conversation, and we got other folks coming on our show, both from the nuclear world, the gas world, the solar world, to help us think through not just the technologies, but these complications. But there's a lot there. And that's just one area that you've talked about today. There's a dozen of them.
Right,
We live...
I think we covered quite a bit of
Hey, before we go, I know we just have a few more minutes. You mentioned something in passing I thought was really cool. My perspective of data centers really is just the States. I have some anecdotal information from friends that come from Europe and Asia Pac. Really, Europe, I suppose, would be the next closest in scale to what we do here. And I know you're connected to operators in the Nordics. How are they thinking through? They're not just European, excuse me, but they have this really unique geographic area that they're building and operating data centers in. How are they thinking about where are areas either that they're innovating, maybe ahead of us, or just differently than us? Whether it's in the design or the operate or even in the build process. I'm curious. I know you've got experience in that area. Well, what can you tell us about what's going on there?
Well, they have some significant advantages over the rest of the world because the majority of the power generated in those in the Nordics is green. It's the extreme case is Iceland, right? 60% is hydro, 40% is geothermal. There is no coal, there is no natural gas. It's green, and the power. The Nordics, Norway, Sweden, Finland, Denmark. Depending on location, but a lot of it is much greener than the rest of Europe, or much greener than the rest of the world, actually. The cost of electricity is lower, although some of these countries now are imposing a 4 cents per kilowatt hour additional tax. That they're still much lower than most European countries. And then certainly they have the benefit of climate, right? It's cooler there, so that you obviously still need liquid cooling for AI data centers, but more conventional cloud or enterprise data centers benefit from that cooler climate. What's different about the Nordics, at least my observation, is that ESG in general and carbon and sustainability, green is more of a priority there than it's here or other, even certainly higher than in Asia or other parts of the world. The Nordics are really very keen on creating a carbon neutral environment. They're spending the money and beyond that, even the whole ESG has a much in my opinion, I don't have actual data to substantiate that, but in my opinion, ESG it's a much bigger factor there than it's here or other parts of the world. They are making significant progress in deployment there. All these countries, Norway, Sweden, Finland, Denmark, and Iceland have a large population of data centers going there because of these factors. Sure, latency is a factor to a certain degree, but the distances are not that great in Europe, and secondly, we can go beyond the Arctic Circle there, and power is abundant, and it's very difficult for that power to be brought to the rest of Europe because of the length of the transmission lines. And when you build a AI training the data centers, probably latency is not all that it's critical anymore. So there are significant advantages for this country has compared to the rest of Europe. And look at Europe. Cost of electricity is double, sometimes triple the cost of electricity in the United States, and that's one of the reason. There are a lot more big AI data centers in the United States than there. I mean, look, United States, half of all the data centers in the world are in the United States, and this ratio is not going to change dramatically in the next few years.
Are they the same size data centers?
No, they're not. They're not. Although now there are discussions about mega data centers. Mega data centers mean hundreds of megawatts, and there are projects there are projects in the works right now that will bring the size to these hyperscale needs, the hundreds of megawatts. But right now you won't find too much. But there are construction in addition to the Nordics and Spain and a few other parts. The main destination, as you know, the Frankfurt, London, Paris, Amsterdam, and Dublin, they are pretty much maxed out in terms of ability to bring new capacity there. Maxed out in terms of power availability.
Not unlike the United States, where we're trying to find other places to grow and expand and try to find the power. Although I'm feeling really pretty good after this conversation. I finally found one area that I think I might be able to compete with the genius of Peter Gross. And I thought you were going to lead with the advantage of the Nordic countries is they have the best disc golf courses in the world. And so you could attract, employees like me who want to come and play, only 4 months of the year because the rest of the year it's so freaking cold you stick to the metal. But other than that, it is Finland, Norway certainly lead the world.
Well, I can tell you that I've never seen a country more addicted to golf than Iceland.
Well, Iceland plays regular golf. I'm talking about frisbee golf.
Oh, wow.
Yeah, frisbee golf. The world's changing, Peter. The world's changing.
It sure does.
Hey, let me ask you this. We're about to go. So thank you, one, for giving us this much time. I can't even believe we got you on here, and I'm so grateful. But if you're sitting down and you're having a consultancy conversation, either as a friend or as an investor or business leader, and you're talking to people, sort of two sides of this question. One, this is what to be excited about, and this is what should keep you up at night. Like, how do you, what would that be? Is it the same answer, the innovation, the opportunity, and what should scare you is the lack of innovation and the opportunity? I mean, how do you answer that two-part question? This is what's exciting and I'm looking forward to. Here's what should keep you up at night.
Well, just like you said, there are two sides of the same coin. It's new and exciting and big, and that's so attractive to engineers and the profession in this domain. But in the same time, you build something that will, $2 billion thing, and it better work. Work is design. So you use a lot of sleep thinking about that. If you are a CEO of a company like this, or a management part of the management team, you have to think about you make all these investments. How long is this cycle is going to be? Is this a bubble? Is going to continue for 5 years, for 10 years? How soon are we going to transition to inference and edge and so on? These are major decisions that have major implications. So, fortunately, I'm not spending my money on building data centers. Even I, believe me, I lose sleep thinking about these kind of things. But I think but like anything else in our civilization, we'll resolve this issue. Will be, and I think that we'll make a better world out there. There are all these concerns, issues with AI, what it's going to do, but I think that the amount of positive things that we're going to bring to mankind are going to dwarf all the negative things that AI will bring. So I'm optimistic. I'm very optimistic about the future.
I am as well. You said earlier, we don't even know how machines learn. Well, we don't know how Tylenol works either. We just know it does, right? And so we take it in moderation. We don't know how consciousness works. We have hypotheses, but we still move forward with psychoanalytics and these other things and trying to help people. I think we're going to keep doing that. And I also don't think we're wrong. This infrastructure, all of these things are going to be needed. We may be early. Like if you started our conversation in your history about riding through that .com boom and bust. No, those people weren't wrong. They were just early. We overestimated. I hope we're not early. This is pretty significant for all of us to be early. And one of the things, hopefully through conversations like that, and I know some of the back office conversations I've been in, thankfully some with you, we're asking each other hard questions. So how do we do that? How does this actually work? Do we have the supply chain infrastructure? Do we have the training? Do we have the rare earth materials? Like on and on. What's the implications of this? The regulation, all of these things. And we're trying to do these things together. And most of us are veterans of that 99 to 2003 era. It was really, really, really hard. A lot of penny stocks out there that collapsed and went into nothingness. I'm not sure.
I think this is different. I think that the magnitude of the AI impact is going to be its order of magnitude higher than the impact of all those data centers that were built in Boscom. So
yeah, I agree. Well, Peter Gross, thank you for coming on the QTS Experience today. It's been my great pleasure to host you. We will link below on how people can connect with you. And if you like that conversation, click the like button. And if you loved it, click the word I'm trying to say, subscribe. Click the subscribe. First day of my new tongue. It's not working great. Thank you, everybody, for joining us. We'll talk to you next time.